Section 2.4 is on other types of equations. This is kind of like the hodgepodge unit or the miscellaneous unit. All of our objectives today are on solving equations, and each equation that we're going to attempt to solve looks slightly different. So again, these are kind of the equations that didn't fit anywhere else. And we'll just run through a whole bunch of examples here. So the first type that we're going to look at are polynomial equations, and I want to solve by factoring. So when I solve by factoring, I'd like to get it equal to 0. So this first guy, to get it equal to 0, I'm going to bring the 27x squared over by subtracting it. And now we're ready to factor. So I would look for the GCF, the greatest common factor. What can I divide out of both of these? You should say a 3 and an x squared. So in parentheses, if I write what's left, from the first set, if I divide by 3x squared, I have just x squared. And from the back set, I just have 9. Now, if you wanted, you could factor this even further because in parentheses here, we have the difference of squares. So if I break that apart, remember the difference of squares, it would be x and x, 3 and 3, and we had 1 of each sign. Now that we have it factored all the way to actually finish solving it, since there's multiplication between these pieces, I set each factor equal to 0. And now we're going to solve it. I'm going to start on the right side here. So to solve this one, I would just have to add 3. So I get x equals 3. There's one answer. Next one, I would have to subtract 3. And I get negative 3. There's another answer. A couple of steps for this last guy. First, I would have to undo this multiplying. So divide by 3. And I'd get 0. And now we have to get rid of the square. So I would square root both sides. Now technically when we square root, we would get plus minus in front, but a plus 0 and a negative 0, they're both still 0. So if you wanted, I guess you could say you have 0 twice. There is a word in mathematics for that when that happens. We'll look at that down the road. So you can see I have 4 answers. 2 of them are the same thing, but I do have 4 answers, and that's not a coincidence. With polynomials, the highest exponent is the number of answers you will have. Now, when you're typing this in for your homework, though, you would just say this as your answers. If you get an answer more than once, you don't have to type it twice. Okay, let's look at the next one. Before doing any factoring, I want everything on one side. So I'm going to subtract the 4x over, and I'm going to subtract the 4 over. So now I'm equal to 0. So now the question is, how do we factor this one? Well, since I have 1, 2, 3, 4 terms and I want to factor it, this is factoring by grouping. So we're going to group, make sure that negative goes with the 4x. So from the first group, I'm going to take x squared out. Now from the back group, I would like to get an x plus 1. So hopefully you see you would have to take a negative 4 out. Since both my groups have x plus 1, we'll remove that. And we have an x squared minus 4 in the other group. If you really wanted to, you can break this second set down further because that is the difference of squares. Into x plus 2 and x minus 2. And now we are going to set each factor equal to 0 and solve. So I get -1, I get -2, and I get 2. 3 answers. And it makes sense because the highest exponent of my polynomial was 3. Okay, what if we have an equation with a radical in it and we want to solve? What I tell people, if you're solving a radical equation, so if it's a square root or a cubed root, we want to get the radical alone. That is our goal with this type. So if I look at this equation and I want to solve it, the only thing with this radical currently is +2. So that +2 has to go away. So I'd have to subtract it over. Once the radical is by itself, now we're going to get rid of the square root. So what would cancel a square root? Well, we'd have to square it. And just like what we've done any other time we've solved, if you square one side, you have to square the other side. If you do it to one side, you have to do it to the other side. And I'm squaring the whole side. So the beautiful thing is on the left, I have just 2x minus 1. That's why I squared it, to get rid of the square root. Every once in a while, my students will get a little crazy and mess up the right side. What I recommend, so that you don't mess it up, let's write it twice, because that's what the squared means. And we're actually going to have to FOIL that right side out. We're going to have to multiply it out. So if I do that, first times first, x times x would be x squared. Outer times outer, x times -2, -2x. Inner times inner, -2 times x. And then last times last, -2 times -2 would be +4. I'm going to combine like terms. Sometimes this is where people get stuck. They go, okay, I've got rid of the square root, but what do I do now? Well, from here, because I have something squared, something not squared, and a constant, I'm probably going to factor it. But before factoring, I want to get everything on one side. Some people ask, well, which side do you move things to? Do you move everything to the left or do you move everything to the right? I personally like to keep the leading term, the term with the highest exponent, I like to keep it positive. So I'm going to bring the 2x and the 1 to the right side. Really, it doesn't matter which side. So when I subtract 2x over, I will now have x squared minus 6x, and I'd have to add the 1 over. So I'd now have 5. And now we're going to factor it. So I want to multiply to 5, and I want to add to -6. So two numbers that multiply to 5, but add to -6. Should be a -5 and a -1. And now I'm going to set each piece equal to 0 and solve. So I'd add 5, and I'd add 1. Now, here's the only catch. Remember when we first started solving, I said, to know if you've done it right, you can always substitute your answers back in to the original and see if it balances out. If square roots are involved, you want to always double check your answers at the end because something funky could end up happening. So watch what happens. So one of my answers that I got was 5. If I plug 5 back in, so 2 times 5 minus 1 plus 2 equals 5. All right, I'm plugging 5 in for all the x's. So 2 times 5 is 10 minus 1. I get square root 9 plus 2 equals 5. Square root of 9 is 3 plus 2. I would get 5 equals 5. Great. That confirms that, yes, 5 is a solution. But watch what happens when I put 1 in. 2 times 1 minus 1 plus 2 equals 1. I'm plugging a 1 in for the x's. So 2 times 1 is 2. Minus 1, I'd get square root 1 plus 2 equals 1. The square root of 1 is 1. Plus 2 is 3. 3 does not equal 1. So what that means, I'm actually going to throw that answer out. It's not actually an answer. When that happens, that's called an extraneous solution, meaning it's actually no longer an answer. So anytime you have square roots, you want to double check your answers, because through the math that happens when you're solving with the squaring, sometimes you get answers out that are like fake answers. So on MyMathLab, if you would have entered both of these, you would have got it wrong, because the 1 is not actually an answer. All right, moving on. Equations with rational exponents. There is that word again. Remember, if a number is rational, it can be written as a fraction, or as a decimal. It will stop, or it will repeat itself. So if I have a rational exponent, it might be like m over n. Let's see how we tackle problems with that situation. So solve. I don't like how this font came out. This is what it should look like. That 3/4 is the exponent. So if I want to solve this, we're going to treat it just like we normally would with any other type of problem. So first what we're going to do is add 6. We're trying to get the x alone. And then hopefully you can see the next step that we would do is to get rid of this 3. Since it's connected by multiplication, I'm going to divide. And now the last step is to get rid of that 3/4. Well, there's a mathematical property that says if I want to get rid of that 3/4, it's like I can raise it to the reciprocal fraction. So I'm going to raise both sides to the 4/3. If I do it to one side, I do it to the other. So what ends up happening on the left, they cancel, and I have just x. And now this is where we have to decide, is this answer simplified? If you type 2 to the 4/3 into the calculator, you're going to get a decimal. And usually we avoid decimals because then you have to round and cut off part of the answer. The other way I could think of this answer, if I write it in radical form that we did a few sections ago, remember the bottom number is the root, and the top number is the exponent. So this is a way to check to see, is your answer simplified? So the cubed root of 2. 2 is not a perfect cube, so I know it won't simplify any further. I can't physically reduce this answer anymore. So if you were entering your answer, this is what I would be looking for. You would just say 2 to the 4/3. It's cleaner than the decimal answer. Let's try another one. If I want to solve this one, people are often tempted to try and subtract the 5 first, but notice it's inside of this exponent. So it's actually the exponent that has to go away first. So I'm going to raise both sides to the reciprocal exponent. So then on the left, they cancel, and I have just x plus 5. Before I deal with the 5, let's check the right side to see if we can get it to simplify. So 4 to the 3/2, if I wrote that in radical form, the bottom number is my root, so it's a square root. I'm not going to write the 2. and then it's cubed. Well, this can simplify because the square root of 4 is 2, but then I have to cube it. So 2 cubed is 8. So what ends up happening, this right side ends up becoming 8. Hang on just a moment here. Okay. Now, I wonder if you're yelling at me or not, because I have technically made a mistake. We took the square root of a number, and remember, when you take the square root of a number, plus minus should appear. So when I cube this, I actually get plus minus 8. So now I'm going to subtract 5. And 2 answers are going to come out of this. My 2 answers, I'm going to do negative 5 plus 8, and I'm going to do negative 5 minus 8. So there's my 2 answers, 3 and negative 13. So watch out for that plus minus. If you physically, in a problem, if you physically draw in the square root and it wasn't there before, then plus minus needs to appear. All right, moving on, equations that are quadratic in form. So we are still going to factor these. And what oftentimes throws my students off with these types of problems is that it's an x to the 4th. But because I have 3 terms, I'm still going to factor it the exact same way I normally would. So I want to multiply to negative 9, and I want to add to negative 8. So 2 numbers that multiply to negative 9 and add to negative 8. Negative 9 and 1. If we rewrite it, okay, so I rewrote the middle terms and kept the first and last the same. Now it's a grouping problem, just like we've done before. So from the first group, what can I take out of both? I should say an x squared. Now notice the other group, it's already x squared minus 9. So if you want, you could say, oh, I'm factoring out a 1, but really we're not taking anything out because it's already good to go. So then I would have an x squared minus 9 and an x squared plus 1. Now if you want, one of these will actually factor down further. This guy is the difference of squares. So I could break that apart further to x plus 3 and x minus 3. Now the x squared plus 1 will not factor because it's not the difference, it's addition. That will not factor down. So now I'm going to set each one equal to 0, and I will get my answers. So I get negative 3. I get 3. Now be careful with this last one. I know I'm going to be expecting 4 answers, so I would subtract 1, and then I have to square root. Now I know you're going to slap that plus minus on front because we took in the square root here, and the square root of a negative, remember, came out as I. So my other 2 answers would be a positive 1i and a negative 1i. So I have 2 real answers and 2 imaginary answers. And there's my 4 answers total. Let's try another one. Ooh, dreaded rational exponents. But we're going to do it the same exact way. So because there's 3 terms, I'm going to try factoring it. Let's marf it here. So I want to multiply to 10, and I want to add to 11. So that has to be what two numbers multiply to 10 and add to 11? A 10 and a 1. Okay, so I'm rewriting the middle term. And now let's group it. So from the first group, what can I take out? Well, I can definitely take a 5. And this is sometimes hard to spot, I can take a 1/3. So think about it. If I took a 5x to the 1/3 out, technically what's left is still a 1/3. And on the back one, I would have just 2. The other group is already x to the 1/3 plus 2, so if you really want, you can set a 1 out front. But we don't have to take anything out. So one of my groups will be x to the 1/3 plus 2 and 5x to the 1/3 plus 1. And now let's set each piece equal to 0 and solve. So if I want to solve the first one, I'd have to subtract 2. And now the question is, how do I get rid of that 1/3 exponent? Well, we're going to do the reciprocal exponent. And the reciprocal exponent would be 3 over 1, or just 3. So they cancel. And I just have to do -2 cubed. So one of my answers is -8. The other one, I'd want to subtract 1. Then I have to get rid of that 5, so I'm going to divide. And now I have to get rid of the 1/3, so I'm going to cube it. So they cancel. Now, if the fraction scares you, remember you can treat it like this. You can do -1 cubed, and you can do 5 cubed. Just do it to each. So -1 cubed is -1, and 5 cubed is 125. So this is a funky looking answer, but it's -1 over 125. Okay, the last type of equation that I would like to solve are equations involving absolute value. Absolute value, so if I had like this, the absolute value of -7, they turn something positive. What the absolute value bars represent is how far away is the number from 0. So all this is saying, it's telling me that -7 is 7 units away from 0. So if I had something like this, the absolute value of 4 is 4. 4 is 4 units away from 0. So my students always just think the absolute value bars always turn something positive. So if I gave you a simple equation like this, the absolute value of x is 2, and I said, solve that. A lot of people would say, well, the answer is 2. And I would say yes, but I would also say no. I would say there's another answer that x could be. -2 would also be a solution because the absolute value of -2 is also 2. So the absolute value equations are not hard to solve, but people will forget about the second answer. So let's try this. What you want to do when you solve these, kind of like what we did with the square root problems, you want to get the absolute value bars alone. So notice on this first example, they are alone, right? It's just everything inside the absolute value bars on one side. So we're ready to get rid of the absolute value bars. So I want you to think, we're going to make 2 equations when we do this. What we're going to do is we're going to take 2x minus 3 equal to 11 without the absolute value bars. And we're going to take 2x minus 3 equal to a -11. The reason why we're changing the sign goes back to the business I was just talking about. We're taking into account that there's going to be two answers. And now it's just two problems to solve. So I would add 3 and divide by 2. So one of my answers is 7. And the other one, I would add 3 and divide by 2. So I have two answers, 7 and -4. Okay, let's try this next one. If I want to get x alone, I really want to get the absolute value bars alone first. So the 5 and that 15, they have to go. So let's add 15 over. And then how do I get rid of that 5? Well, it's connected by multiplication, so I'm going to divide it. Now that the absolute value bars are alone, I'm ready to make my two equations. So 1 minus 4x equals 3, and 1 minus 4x equals -3. And now I'm going to solve them. So I'm going to subtract 1, and I'm going to divide by -4. So this 2 over -4, I would like that simplified. So 2 goes into both. So I get -1 over 2. And the other one, I should get +1. All right, and the last problem I'd like to look at is a story problem. The formula, and then it gives me the formula, which has a radical in it, models weekly television viewing time, which is H, by annual income, which is I, and it's in thousands of dollars. What annual income corresponds to 44.6 hours per week watching TV? So what this is basically saying is, if I watch this much TV, what is the income that I could expect to be associated with it? So we're going to substitute 44.6 into either H or I. So notice I'm looking for the income, which is I. So I'm looking for I, and they gave me the hours, so I want to substitute in for H. And so now I want to solve this. Since it contains a radical, I want to get the radical alone. So let's subtract. So if I subtract them, I would make sure you can do this in your calculator as well, that you get these decimals. Okay, now to get the radical alone, I'd have to get rid of that -2.3. And right now there's multiplication, so I'm going to divide. So if I divide those, I get 10. And now the last step is to get rid of the radical itself. So I'm going to square. So I equals 100. So now I want you to tell me, what does that mean in this problem? Well, it's representing income, and it was in thousands of dollars. So we would say, if you watch 44.6 hours per week of television, that corresponds to an annual income of $100,000.